Good morning everyone. Hope you all are fine. So in my previous video, I have already explained about the rotation of the earth and about earth's axis. Now in this video, I am just going to explain about the revolution of the earth. So what is revolution of the earth? So earth moves around the sun in a fixed path, and this fixed path is known as orbit. This orbit is elliptical in shape, and earth revolves at a speed of 29.8 kilometers per second around the sun and complete its one revolution around the sun in 365 days and 6 hours. Earth takes 365 days and 6 hours to complete its one revolution around the sun. As we know that there are 365 days in a year. So rest of the 6 years, after every 4 years, we are having 366 days in a year. So that year is called the leap year. So what is this leap year? So leap year is the year in which instead of 365 days, we are having 366 days. So why we are having 366 days? Because earth takes 365 days and 6 hours to complete its one revolution. So that 6 hours are added, and when it becomes 24 hours, one full day, that one full day is added in the month of February, and in the leap year we are having the February month of 29 days. So how to calculate the leap year? That this year is a leap year or not? So for calculating, for finding out whether the year is a leap year or not, simply just divide the year by 4. If it is fully divisible, it means the year is a leap year, and if it is not divisible, fully divisible, then the year is not a leap year. Just like now we are having 2020, the year 2020. So if we divide 2020 by 4, it is fully divisible. It means in this year we are having 29 days in the month of February. So next is unequal days and nights. We know that Earth's axis is inclined to the Earth's orbital plane. So it is always slightly tilted in the same direction as the Earth revolves around the Sun. This makes each hemisphere tilt towards the Sun during half the year, that is for 6 months, and away from it during the other half. So in this way, for 6 months the northern hemisphere inclined towards the sun, and for the next 6 months the southern hemisphere inclined towards the sun. So due to this, unequal days and nights are caused. So let's understand how it happens. So when northern hemisphere tilted towards the sun, let's understand with the help of this diagram. So it shows the situation during that half of the year when the northern hemisphere is tilted towards the sun and the southern hemisphere is tilted away from it. If we measure the parts of the equatorial circle which fall in the lit and dark zones using a piece of thread, we will see that both the lit and the dark parts of the circle are equal. That means duration of day and night on any part of the equator is equal. It is of 12 hours day and 12 hours night. So now let's move from equator towards the northern hemisphere. So when we move towards the northern hemisphere, the length of the lit part of a parallel is more than the dark part. It means that days become longer and nights shorter from the equator towards the North Pole during this half of the year. A small region around the North Pole falls only in the lighted part. In other words, this area around the North Pole has 6 months of daylight. In the southern hemisphere, the situation is just the opposite. As one moves from the equator to the South Pole, days become shorter and nights longer during the half of the year. The area around the South Pole is in darkness. In other words, places near the South Pole have 6 months of darkness. Now next is southern hemisphere tilted towards the sun. So during the 6 months when the southern hemisphere is inclined towards the sun, during this time also at the equator, the days and nights are of equal duration. So we can say that the inclination of the Earth's axis does not affect the duration of days and nights on the equator. Thus, places on the equator always have days and nights of equal duration. During this half of the year, places in the northern hemisphere have longer nights and the shorter days. Places near the North Pole have only darkness and no light. In the southern hemisphere, the days will be longer and the nights shorter. The area around the South Pole has daylight and no darkness for this half of the year. That means North Pole is having 6 months night and South Pole is having 6 months day. Next is change in amount of heat received. The portion of the earth which is tilted towards the sun receives more direct rays of the sun. The other portion receives more slanting rays. The inclination of the sun's rays at a given place keeps changing throughout the year. The amount of heat that any place receives depends on the inclination of the sun's rays. The amount of heat is greater when the rays are vertical. This is mainly because of vertical rays of the sun get concentrated on a smaller area, whereas the slanted rays get spread over a wider area. Thus, the vertical rays cause more heating. In the morning, when the sun's rays are slanting, it is cooler. But as the day advances, the sun's rays gradually become more direct. You must have noticed that midday or noon is the hottest time of the day. After this, the sun's rays gradually become slanting again. That is why the temperature starts falling as evening comes. So this is enough for today. Tomorrow we will discuss about the change of season due to the revolution of the earth around the sun. So till then, thank you and have a nice day.